Let us do an activity to prove the Newton's second law of motion. The materials required to do are graph paper, a rubber band, two marbles of different masses, and a scale to measure the distance. Fix the rubber band to the graph paper board like that. We know that pushing or pulling on object is called force. Let us apply the force by pulling the rubber band to different distances like 2 centimeters, 3 centimeters, 4 centimeters, 5 centimeters, 6 centimeters, like that. That means we are applying different forces as we are pulling the rubber band to different distance. Pull the rubber band up to 2 centimeters and release the marble. Now let us calculate how much distance has it traveled and the time also. How much time it taken to travel up to this distance?
4.7 seconds.
How much distance it traveled? 200 centimeters. 200 centimeters. Time 4.7 seconds. Speed 42.7 centimeter per second. Let us release the marble at 3 centimeters distance. Traveled by this object is 395 centimeters. The time
7 seconds.
Pull this object at 4 centimeters distance. The distance traveled 440 centimeters. The time is 6 seconds. What happens when we increase the force?
Acceleration is increasing.
Here, the mass remains constant. When we apply the more force, the acceleration produced in the object is more. That means acceleration produced in the object is directly proportional to the force. Let us apply the same force on smaller mass object and larger mass object. (450 centimeters). 4 seconds. 112 centimeters per second. Pull the larger mass object with the same force. (4 centimeters), 210 centimeters. Time 5.6. Speed 37.5 centimeters per second. What about the acceleration?
Decreasing.
The acceleration is inversely proportional to the mass if force remains constant. Which object has less acceleration?
Heavy object.
From this activity, we are concluding that the acceleration is directly proportional to the force we applied if mass remains constant. This acceleration is inversely proportional to the mass if force remains constant.